greater as well then, yeah. Okay, so if we can all listen up then. It will look a bit better once the writing pad comes up. It's because it's black at the moment. All the way, please. Thank you. Yes, keep going, keep going, keep going. Yes, thank you. Right, okay, so we'll continue now. So last time we were looking at factorizing. So what we're going to have, come on now, please, thank you. So what we'll have a look at today is numbers of this form. We are starting, so please be quiet, thank you. Yeah. So for this lesson, we're looking at numbers of this form, and these are called surds. Again, for those who had an American education, another name for this? Yes? Huh? No? Oh, come on. No, come on. Yes, the other name for it? No. Radicals, isn't it? Yes. All right. Now, surds. So we'll just have a look a little bit at some basic ideas here. So I'll just take something for example. No, it's not going to work unless you're quiet. Please. I'll just wait until I have quiet, then to continue. There should be no questions at this point because all I've literally said is these are called surds, and that's all you need to know. Right, so our first actual example of surds. For example, we have here square root 108. Okay? This can be simplified, and I want to show you the way you can simplify it. Okay? And the way you can simplify it is by using something called a prime factor tree. Now, you'll know this the moment I do it, and it's something that you probably did in elementary school. So watch. You take 108 and you think of any two numbers that multiply to make 208. So for example, 2 and 54. Any two numbers that multiply to make 108, except 1 and 108, because obviously that's true. So 2 and 54. Now what about 2? Any numbers here that make 2? Well, just 1 and 2, which we're not going to use. So we have to stop here. 54 could be 2 and, for example, 28, isn't it? No. 27. Again, we stop, and 27 could be 3 and 9. So with 3, again, we stop, but 9, 3 and 3. So what you have in the boxes here, these are called, does anyone know? Prime factors, yeah. These are all prime. So having these prime factors really helps in the simplifying. And if you're wondering, does it matter what pair I choose? It doesn't, because everyone will get the same primes at the end. So it doesn't matter, okay? So what you do next is you try to group your primes into pairs. So for example, you can say 108 is 2 multiplied 2, which is 2 squared. Also multiplied by 3, multiplied 3, multiplied 3. So you could say it's 2 squared multiplied 3 squared multiplied 3. Or if that's a bit confusing, what I'm actually doing is I'm saying 108 is 2 times 2 times 3 times 3 times 3. That's what I'm really saying. But it's more useful to group them as pairs. 2 squared, 3 squared, and 3. Now the reason I'm saying it's more useful to do it that way is because when you have a square root of like A, B, C, it's the same as root A, root B, root C. Well, this is what we're getting to. So here, this could be root 2 squared, root 3 squared, root 3. Yeah. Now the first one is easy. What's root 2 squared? 2. Yeah, root 4, which is 2. So this and this cancel. So you're left with 2. Here, this and this cancels. You're left with 3. And here, nothing. So it's just root 3. 2 times 3? 6. So the final answer is 6 root 3. So this is a fully simplified. You can't simplify it anymore. Okay? So am I right in thinking that some people remember doing this in elementary school? Because I remember doing this in elementary school. So middle school. Okay, close enough then. Elementary school, middle school, you should remember it. Yeah, make your teacher happy then. Okay, I'll give you one example to try and then I'll do something different. Can I scroll down? You have this? Okay, so just for practice, you try this one. Root 2, 4, 5. Try and simplify that for me. Root 2, 4, 5. I'm missing one person. Can anybody spot who's missing? No one can notice? Okay, well I'll just pass this around and tick your name off then. So just put a tick beside your name and pass it around then. Could be, haven't done it yet. But I think it is, yeah. Yes, got it, yeah. American education? Yep. America is the only place I hear them use radicals for square root. So. Okay, I think that should be enough time. So, 2, 4, 5. Well, you can definitely see 5 goes into it. Yeah. 49. This is 7 and 7. So this one's quite easy. It's quite short. This will be square root 7 squared 5. So the answer will be 7 root 5 then. Yeah. Yeah, that's okay, isn't it? Yeah. Right, let me do another example for you. If I can scroll down, yeah. Okay, so we want to simplify something like this, root 624 plus root 39. So I'll do this one then. So before I do it, I'll say it. This is not this. Okay? No, not this. Only when it's multiplied and divided, not like this. Okay. So what we need to do here is we need to simplify each of these. Okay, so let's start with the bigger number first. Root 624. Okay, so 624, well, that's definitely going to be a 4. I can see that at least. So that's going to be 131. Is that right? No, that's not right. 156, is it? Thank you. That definitely is 2 and 2. And this will be 3 and 52. Okay, so that's a 3. 52, 2 and 26. 2 and 26. And 26 will be 2 and 13. Yeah. Okay, so that's okay. So 624 will be root 2 squared, another 2 squared, a 3 and a 13 plus root 39. This will be 2 times root 3 times 13 plus root 39. This will be 4 root 39 plus root 39. Just put a tick beside your name there. Done? Okay. No, I think they got it over here, so...
he changed, it's not over here anymore.
So this is the... Oh, that's why I have one left.
Yeah. He's not here anymore. He's gone.
So why is there a tick beside his name?
No.
Oh, this one?
Yeah.
That makes more sense. Right, so they're in engineering, is it? Or they just left?
I think he's...
Oh, he's in English class.
Yeah.
Okay, that's fine. Right, and the final answer here? What's the final answer here? 5 root 39, because it's like there's a 1 here. So 4 root 39 plus 1 root 39 is 5 root 39. They can add together. So it's like 4x and 1x is 5x. So we do it the same way, we have to simplify it. So again, I'll give you one like this to try. Let me just scroll down a little bit. Question? So I'll have you try root 128 minus root 32. Try to simplify that. Yep.
The last one.
Yeah.
6 to the square can be done as 2 and 12, right?
The 26?
No, 6 to the 12.
The 6? Oh yeah. This here? Yeah.
Yes. Can we do it in another way?
Yeah. So what would you have like here, is it?
2 and 312.
Yeah. If you continue this way, you should get the same numbers.
I can
Yeah.
do it like this and I got the same.
You got the same, yeah. It doesn't matter which choices you make. You should get the same prime numbers at the end. And that's absolutely fine. Yeah. Okay, so I want you to try this one for me, please. I hear something which is not English. That's better. Okay, try this one. Finished? Great. Yes. Oh, you didn't have... Looks okay. I'll have to do it now, but yeah. I can't spot a mistake at a distance, but it looks okay. Yeah, I think that's what you got as well, isn't it? Yeah. Huh? Which number? That's not what we're getting over here. Double check. I think so, yeah. Okay, let's have a look at it. Right, 128 would be 64 times 2, and 64 is 2 times 32, and 32 of course is 4 times 8, and 8 is 2 times 2, and we can just jump to the end. 8 is 2 times 2 times 2. So how many have we got? 1, 2, 3, 4, 5, 6, 7. Is this? Yeah. So we can have this as 2 squared, 2 squared, 2 squared, and a 2. And 32, well, maybe we can just do it. 2 times 2 is 4, times 2 is 8, times 2 is 16. There's 5 of them. 2, yeah, okay. So that would be minus 2 squared, and a 2. So 2, 4, 8. This is 8 root 2 minus 4 root 2. 4 root 2 then. is what we have here. Okay. Yeah. Did you find your mistake? Yes? Okay. Alright, let's move on to something a little trickier. Can I scroll down? Yeah. Huh? You have one sip of coffee.
Coffee's amazing.
Not this one, I made it myself. Alright, let's move on to something a little more difficult. Okay. Can I scroll down? No? One more sip for the people at the back.
Best coffee ever.
No. Quite the opposite. Right. Let's have a look at this example. Root 240 plus root 2 bracket root 15 plus root 18. Now, you can see, well, what's one issue straight away with this? Yeah. Well, basically, the biggest problem I can see is that each root is a different number. There's nothing similar between them. So we want to try and simplify each of them. 240 is 24 times 10, and 10 is 2 times 5. 24 is 2 times 12, and 12 is 4 times 3, and 4 is 2 times 2. So we have 2, 2, 2.
4 twos and
Let's see. 4 twos, a 3, and a 5. Is there anything we can do with this 2? Nope. The 15, 3 and 5. And then the 18 will be 3 and 6. And then this will be 3 and 2. Okay. So we'll try and just do these directly. We'll have a 2. We'll have another 2. So on the outside I can see there will be a 4. And on the inside there will be 15. Good. Plus root 2. And here this will be root 15. And on the outside what do I have? A 3, and on the inside 2. Okay, so that's a bit better, yeah?
Why is 18? Why didn't you use 2 times 9?
You could have, and you'll get the same answer. Yeah. Okay, so now it's a little bit better because at least we have similar roots in both terms, so it'll make the multiplying a little bit easier. So again, the order is going to be like what we did last time. It'll be this one times this one, this one times this one, and then this one times this, and this one times this. So the first one, 4 root 15 multiply root 15. Well, what happens? Root 15 and root 15 make 15, yeah. Times 4, 60. 4 root 15 by 3 root 2. Well, on the outside it'll be 12. And on the inside it'll be root 30. Good. Root 2 by root 15, there's nothing on the outside, and on the inside, root 30. And then finally, root 2 multiply 3 root 2. So root 2 by root 2 is 2, multiplying the 3 makes it 6. So the answer will be 66 plus 13 root 30. Very good. Okay, so you can use your calculator a little bit here if you need to, but in the exam, what they want to see, they don't need to see all this rough work in the exam. So to get full marks in the exam, they want to see you simplify, expand, and then simplify, group together at the end. So for example, this is probably a 3-mark question in the exam, and the marks would go like this. Okay.
It would be bad, but it's okay to write all the rough words.
Oh yeah, it's okay. I'm saying you won't lose anything from not writing it. Yeah.
12 was 13, 13. Isn't it 12?
This is 12 and this is 1,
Oh,
making
sorry.
13 altogether. Yeah. Yeah. Question? No? Okay. Have you done problems like this before? Or is this...
This is like
Of course.
middle
Okay.
school, middle school.
Um,
I don't know.
towards the end of middle school, maybe.
No, it was the beginning. It was grade 6.
Yeah? Okay. Right. Listen. I'll give you one like this to try, and then I'll do it, okay? So let me just... I don't know, we'll say... Listen! You can work together in 30 seconds. Not when I'm talking. Root 32 plus root 5. Bracket root 2 plus root 125. Okay, now you can work on this. Haven't done it yet, so I don't know. Sounds believable, though.
Wait, when the 2 comes out, do we plus or times? Like if there was 2 2s over here, when they came out, yeah, they came
Are they
out.
times?
Times, alright.
Finished over there? Yeah? Okay. We'll have a look, so. Okay, let's have a look at this. Do you agree with that answer? Yep. Okay, let's have a look at this now. You can use the prime factor tree, but as you start doing more of these, you might become more confident to do it a little bit quicker. So for example, you might say, well, I know 32 is 16 times 2, and 5 is root 5, and 2 is root 2, and 125 is 25 times 5. Yeah. So if you can do that, that's great. It lets you save some time, because you can see here, well, this will be 4 root 2. This will be root 5, root 2, and 5 root 5. Okay, let's multiply. 4 root 2 by root 2 is 8 in total, isn't it? Yeah. 4 root 2 by 5 root 5 will be 20 root 10. Root 5 by root 2 is root 10. And root 5 by 5 root 5 is 25. So what's that? 32? No. Huh? There's a mistake here? Hang on. Right or wrong? Okay, great. Doesn't matter. Right. 33, no, 33 plus 21 root 10. You seem very passionate that I made a mistake. Why do you think the mistake is? No, not you. I know not you. Mistake? No? Are we all okay? Yes? Okay. Right. Did people get the same answer? This 33 plus 21 root 10?
Yeah.
Is that what you got? Yeah. Oh, we're not happy down the back. We look very unhappy. Yes, go on. Oh, thank you. All right. Okay. So the next example I want to do is when you divide. Okay. Minus 10 plus root 147 over minus 2 plus root 3. Suffer. Does anyone remember from high school the trick to simplifying this? So I know the first thing you probably should do is simplify each of the roots. So maybe we'll just do that first. This will be minus 10, and this is 49 times 3, so that'll be 7 root 3 over minus 2 plus root 3. Okay, now that I've done that, who knows the next step? You didn't think you know. Try.
Easy.
No squares. Yeah, but what the heck is that? So, what do I do? One sec. Wait.
You multiply both the numerator and the denominator.
Yes.
By that, but then you change the sign to minus.
That's it. Change which sign now?
Plus in the middle.
Yeah. So the trick here, it's called rationalizing the denominator. But anyways, the trick is the name is in the worksheet. Don't worry, you'll see it in the question. What's more important is what to do right now. So the trick to simplifying this is you multiply the top and the bottom by minus 2 minus root 3 minus 2 minus root 3. Now, you're allowed to do this because what does this equal in total? 1. And when you multiply by 1, what happens? Nothing happens. So you're not changing the value here. This is why you're allowed to do it. And you'll see the reason why we choose these numbers, because it will simplify what's on the left in a moment. Do you remember the name of this though? The minus 2 minus root 3. It's called the something of minus 2 plus root 3. Conjugate, yeah. So we multiply the top and the bottom by the conjugate. And this will simplify it. So just before I continue, I just want to clarify the conjugate a little bit. So I'll go back to this in one moment. Minus 2 plus root 3. The conjugate is minus 2 minus root 3. Root 5 minus 2. The conjugate is minus root 5 minus root 2. The sign changes on the root. Okay. 4. The conjugate is 4. Only on the root. Root 6 minus root 6. Okay, so the conjugate, the sign is changed only on the root. Okay, just remember that. Be careful with that. Okay, now we'll go back to the question. So we have 2 multiplications to do. On the top, we need to multiply minus 10 plus 7 root 3 minus 2 minus root 3. And on the bottom, we'll need to multiply minus 2 plus root 3 multiplied by minus 2 minus root 3. Yeah? Yeah?
That
Yep.
minus 2 plus root 3 is root 3 minus
If it was root 3 minus 2, then it would be minus root 3 minus 2. That only the sign in front of the root gets changed. Everything else stays the same. Yep.
Root, you mean by root like the bottom only, right?
You only look at what's on the bottom, and you change the sign in front of the root. And that's what you use here.
Yeah, okay. So, just to clarify, I forgot what they call these.
Yeah, well, I haven't actually said it yet. The top line is called the numerator, and the bottom line is called the denominator. Okay. Continue with this? Yeah. Alright, let's multiply out the top, so that won't be too difficult since we've just done an example of multiplying. So on the top we have minus 10 minus root 2, that's 20. Minus 10 minus root 3, that's plus 10 root 3. Minus 7 root 3 minus 2, minus 14 root 3, isn't it? Yeah, and the last one, 7 root 3 and minus root 3, minus 21. Down below, minus 2 minus 2, for minus 2 minus root 3 is plus 2 root 3. Root 3 minus 2 is minus 2 root 3. And root 3 minus root 3 is minus 3. Now, the reason we use the conjugate is because what has happened here, they'll cancel. And the total will be 1. And this cancelling must happen if you did everything correctly. It should cancel. This isn't an accident. This is what should happen. So if it didn't cancel, it means you've done something wrong. And you're right. In total, we'll have 1 on the bottom. In total. On the top, we'll have... Guys, please, don't talk when I'm talking. It makes my life difficult. And trust me, it's already difficult enough. Thank you. 20 minus 21, minus 1, and then here we have minus 4 root 3. Now, if you're wondering, do I always get 1 here? The answer is no, it's just happened in this question I got 1. Usually it's not 1 here. So usually we have to divide each of these numbers by what's on the bottom. But in this case it's actually a nice number. So we finish with minus 1, minus 4 root 3. But again, I'm just saying that it doesn't always have to be 1. It just happened to be 1 in this question, which was nice. Okay, so it doesn't need to be 1. Okay. I'll give you one to try now. Do you have this? Yeah. Okay, well I'll write it down here. So I want you to try minus 63 plus root 504 over minus 7 minus root 14. Okay, try this one. Actually, just before you started, what is the conjugate here? Minus 7 plus root 14. Okay, good. Okay, give it a try. Question? Okay. Here? More? How far? Oh, okay. Well, let me just wait until people write this down and then I'll go back. Did everyone write this down? I can go back. Okay, which one? The previous one? This one? Okay. Okay. Try that question, please. Yep. Okay, let's have a look at this one. So, is the top one 6 root 14? Is that what you got as well? Yeah, great, okay. So, we'll multiply the top and the bottom by minus 7 plus root 14 and minus 7 plus root 14. So, on the top we have to do minus 63 plus 6 root 14 minus 7 plus root 14. And then on the bottom, minus 7 minus root 14 and minus 7 plus root 14. Okay, so what's that? 400 and something, isn't it? 441 minus 63 root 14 minus 42 root 14 plus 84. Now I'm going to skip the middle pieces because I know the middle pieces will cancel, so I'll have 49 minus 14 in the end. The middle two pieces cancel. So on the top, what have I got? Let me see. 441 and 84. What's that now? 525? 525 minus 105 root 14 over 35. Now does 35 go into each of these? It does. So you have 525 over 35 minus 105 over 35 root 14. Well, that's 3 times. So that's 3 root 14. And hang on, that's this 15 times, is it? And that's it simplified there. Okay. So you see, they're all the same. They're all done the same way. There's nothing different about any of them.
Give it a minute, right?
Yes. Write that one down. Okay. Got that? Right, so just two things before we finish. So the homework will be W, X, Y in each question. Okay, W, X, Y.
WXY in
Mhm.
each question.
In each one. There's 4 questions, I think. You'll get that when I make your account after class. You'll see what that is. And you'll see what that is afterwards as well. And
I think I can send to watch that.
you can do that as well, but we'll make the account. Wait, listen, I said there was 2 things. Listen. Listen. I'm waiting for you to be quiet. I'm waiting for you to be quiet. Thank you. Right, so the other thing to say is that you have, I think on the timetable, an extra maths class for later today. Yeah. So, were you told who goes to that? Did your tutor tell you who goes to that? No? Okay. Well, it's only the students that I like that go to this class. Seems like you're believing me when I say this. No? The extra class, I thought your tutor would talk to you, goes about it. I don't really mind who goes to it. It's just an extra hour for more practice questions. There's not anything new in it. So, for example, the 2 new students should definitely, or the 3 new students should definitely go, so you can try and catch up with what you missed then. And there's a couple of other people. Do you have a tutorial today?
Yes.
Ah, well, why didn't you say so? Who's your tutor? No, I am definitely not your tutor. Who's your tutor? No, your individual tutorial. Stephen B. Okay. Yes?
Yeah, with you. Yeah, with you.
Trust me, I would know if I'm your tutor. Yeah. That's me. Stephen Bruce, is it? Yeah. Listen. So, I am Stephen, and the other one is Stephen B. Okay, he is your tutor, as in he has to worry about you. Huh? Oh, there's 2 groups here. That's right. So who's the other tutor then? Susan. Okay. Did you have Susan this week?
As well as better study, but that was yesterday.
That's fine. And the people who have Susan, did you see her this week?
Yeah.
And did she talk to you about extra maths?
No.
And Stephen Bruce, did he talk to you about extra maths? He talked to you, yeah? Talk to anyone else? No. I'll have to talk to these teachers. And they were supposed to tell you who's in this class, and I don't remember who should go to this class. So anyway, for this week, the class will just make it optional. So, I mean, if you want to go, please do. What will be done in this class, what I'm going to do in this class is whatever the students in the class want me to do. So if you want, for example, if you want to do more of these in the class, then I can do them on the board. If you want to practice some and then have me do it, or if you just want to try it and then show me, whatever, okay? It's just a resource hour. Now the reason I don't let everybody go is because the room is, which room is it? B301. And you can see that you won't all fit, okay? So what usually happens is when the class is quite small, I just let anybody who wants to go, and in a situation like this, we have to limit it, okay? So for this week, we'll make it first come, first serve. If the room is full, tough break, you can't come in, okay? So it's up to you, except for maybe the new people I said you should definitely go, okay? And we'll try and catch you up then on what you missed in a couple of lessons, yeah? Do you all understand? But I think for next week the tutor will talk to you. Now, if the tutor says to you, Stephen B or Susan, no, you don't have to go, it's okay, but you want to go, then just tell me and that's fine. I just need to make sure there's enough space, that's all. Okay? For today, first come, first serve. Okay? Okay, alright. We'll leave it there, and then the people who don't have Moodle accounts, just follow me in a minute and we'll make an account then.